Okay, good morning. Good morning to the first class of IGCSE hosted by Guru Niwasa. So I warmly welcome you all to the class, and we are going to go through an introduction about Pearson today. So we'll be discussing what is the Pearson Edexcel curriculum, and I will take you through the topics of the particular curriculum you guys are going to follow now. Okay, and then at the same time we'll see some tips and tricks about the papers, and we'll try to look at the big picture of what we are going to go through and what are these topics and how these topics will affect your knowledge in programming and computing, and how it will give you the ability to learn stuff. Okay, so without taking any time, let's jump in and see what this is. So, syllabus. Okay, perfect. So, this is the total syllabus overview. Okay, so we do have, yeah, so we are basically starting from the syllabus overview itself. So, let's go through it one by one. I'll take you guys through the each topic. Hi, good morning. Hello. I say good morning. Good morning. Good morning. Just now, I just started it through the topics. So yeah. So what I'm going to do is I'm just going to take you through the list of topics and the modules which we are going to cover. So since we just now started it, we can dive in and see what are the points which we need to cover up. Okay, perfect. So yeah, so the class is a bit different from what you have seen before. So I'm in front of a different type of studio. So um, we'll be using interactive slides and presentations so that the class will, I'll try my best to make the class as interactive as much as possible. Okay, so so I'll take you guys through the topics first, and then let's see what it is. So perfect. So problem solving. Now, big problem. Like, so when it comes to software engineering, or when it comes to building applications, the primary issue we have, or the primary let's say the primary reason we build applications is to come up with some sort of a solution to a problem, right? So always software is, or hardware or computers, anything is basically trying to solve a problem, right? Okay, example is if we take a typical telephone connection. Okay, so why did humans invented something called a telephone? Because we wanted to communicate, right? So we did not have any method of communication. Forget about communication. So people needed to have a way of transportation. So they came up with an engine, and after that, slowly, it evolved into a position where we got the motor car. So same thing happened with IT, right? So people had different requirements for different sorry different problems, and in order for to give a solution for those problems, people used computers. So we'll talk about the history when we jump into the third topic. But then again, just to take you through this. The topic number one. So we will be discussing the algorithms, and we will be discussing the idea about decomposition and abstraction. Quick question, Putra, did you guys already finish the topic one, or where are you at school right now? You're on mute. What's it? Yeah. So did you guys finish the first topic at school, or where are you currently at now? I mean the syllabus wise topics. Topic 1 එක ඉවරද නැත්නම් තාම යනවද? Still
It's finished.
Finished it. Okay. Where now? Where are you guys at? Topic two or
Topic 2, sir.
topic two? කියන්නේ programming, right? Programming one. Okay. Got it. Got it. Okay. Noted. Okay. Perfect. Okay. So I'll just. That's perfect. So, but we'll be starting from the first topic itself. So, I'll just quickly take you through the point about algorithms and this whole thing. Eh? So, in order to explain this, I'm using a small, let's say, a small actual problem. Okay, so let's say if you want to, okay, so you want to make a cup of coffee. Okay, so now the problem is literally the making of the coffee, right? In order for you to make a cup of, sorry, you need to drink a cup of coffee. So the requirement or the problem is having a cup of coffee. Now, in order for you to get a solution for this problem, to basically have to make a cup of coffee, there's a certain process you will have to follow, right? So this particular process, that is where we will be coming up with the flow, right? Hold on. Yeah. So what we'll be doing, what we'll do is we will basically first come up with a flow on how to make this cup or how to get this thing solved. Okay, problem. You are, let's say, you're hungry and you want to drink something. So you think about having a cup of coffee. So in order to make this cup of coffee, you will have to go to the kitchen and you will have to find some coffee first of all, kopi pay kopi hadan, right? And after finding the coffee, then you need what else do you need? මොනවද ඕනේ කෝපි එකක් හදන්න? Simple ingredients. You need sugar and also you need water, right? You need water and වතුරටත් වඩා there's another point, you need hot water, right? So there are like different let's say different parts of things you need. So okay, so that's the problem. Now in the algorithms part, what we will do is in this part we will be actually thinking about how you are going to make this cup of coffee with the flow. Huh? Okay, so just think of this as in a process. So you need to find a mug first, right? So finding the mug is also a problem. You don't know where the mug is. හිතන්න මේ අම්මා එක හොදලා කොයි හරි තියලා. Then you have to first find the mug. Okay, finally you found the mug. Then next is you need to find some water, right? And you need to boil some water. First you need to go and let's say you take a kettle and that kettle can be an electric kettle or it can be a normal kettle where you keep it on the stove, right? So all those sub problems are there. So let's say okay, so now you found the kettle. Let's say you have an electric kettle at home, right? So you found the kettle. Then බලන්න ඕනේ current තියනවාද? Now if it is electric kettle, now that is also a problem, right? Now you have to find out, okay, power is there, hari, light එක දාලා බලුවා current තියෙනවා. Now perfect. Then you go to the faucet and you open up the faucet and try to fill it up with some water. දැන් බලන්න වතුර තියනවාද කියලා. Like if it is a water cut, then වතුර නැහැ. On another problem. So now that is also sorted. Let's say okay, water check, water is there. Okay, water found. Okay, pour water. Now done. So after pouring the water, then if it is an electric kettle, of course, then you just need to plug it in and it will boil the water. But there's a condition again, right? If it is not an electric kettle, then if you want to keep it on the stove, then you have to first keep it on the stove and try to light the stove. And in order for the stove to work, you need to have gas. And gas නැත්තම් ඒත් ඉවරයි. හරි. ඔන්න so those are the actual flows when solving a problem. So the same thing happens in software also. So when you are trying to build this, all these things, all these actions should be factored in. Otherwise, without having all these actions in, you will never be able to come up with the actual functioning solution. Okay, so when we jump into this module, I will kind of use many more practical examples because since I was in the industry for a long time, I do have a lot of stories and fun stuff which I will obviously share, and you guys will get the option to see actual live projects as well. Like there are a couple of popular Sri Lankan websites and applications as well, which has been developed by my company. So you guys will get the chance to see those as well. So okay, so now flowcharts shape, then copy එක හදන්නට දන්නවා. Now think about this in another way. හිතමු you get the option to build an application for this. Now somebody is asking you to create a software for a coffee making machine in order for you to make the coffee in a proper way. Then you need to write some logical expressions so that you will get some logical code, right? So in order to do that, in that way, you will be using pseudocode. So pseudocode is basically being used to write the conditions and the program in order for you to make sure that the program works. Don't mix this up. Pseudocode is actual programming language. Those two are two different things. Pseudocode is actually being used to streamline an actual coding representation. Again, different high level language code we use pseudocode to code it and write it in a specific way so that we can test it out. If we have a condition where you check if water is available in the faucet, so you open it up, that particular set of actions which will be converted from the flowchart will be written using pseudocode. So that is where we use pseudocode. And then so that is the base part about algorithms, okay? And then we will be learning something in depth into algorithms. So algorithms, in the sense, there are multiple different types of algorithms. So mainly we do have standard algorithms where we used to do different actions like to sort, to merge, to search through a list of items, and all these type of different actions. So these algorithms are actually commonly being used. Right now itself, then so the data is actually transferred through the internet using a massive lot of different algorithms, because data has to be processed, data has to be transferred, it has to be sorted in a specific way. So all these systems continuously work together, technically harmoniously works together, because it works as a single entity, right? And then that is where this thing works. So we will be technically learning about algorithms, and also when we go through the standard algorithms, there will be a certain development part involved in it as well, because we need to do some hands-on coding, and then only we will be able to understand what it is. Okay, perfect. So then next point about the decomposition and abstraction. Okay, so decomposition. What is decomposition? What do you think? No, just come up with an answer, no problem. There's no such thing as a correct, like an exact answer. What do you think? You're on mute. මොකද්ද compose කරනවා decompose කරනවා කියන්නේ? Okay, no problem, no problem. Okay, no worries. Thanks. So, decomposition and composition, we will basically go through this in depth once we jump to the topic. But just to tell you this in a high level nutshell type of a manner, decomposition means, okay, so let's take the same scenario we talked about where we made the cup of coffee. So in order for you to make this cup of coffee, you will be performing a certain set of fixed actions, right? So high level actions, so we call them high level actions. High level action එක කියන්නේ වැඩේ වෙන්න මොනවද තියෙන්න ඕනේ කියන එක. හරි. So mainly you need to have a cup or a mug, and you need to have some coffee powder. Hari, coffee monohari coffee. It can be Nescafe or any other type of coffee, right? And then you need sugar. If you want to have sugar, yes, you need sugar. Also, you need some milk powder, right? If you want to have milk powder, then if you prefer a milk coffee, then you need milk powder. And on top of that, you can actually use liquid milk as well. Hari? Okay, now that's the gathering of resources part, right? So when you decompose that problem into small components, okay, so I'll explain it in a very simple way. Then hitanna mug එක හොයනවා. හරි, we'll go back to that. You go to the kitchen, බලනවා mug එක නැහැ පේන්නේ. හොයාගන්න බෑ. ඊට පස්සේ එක්කෝ අම්මගෙන් අහනවා නැත්නම් ගෙදර ඉන්න කයෙන් හරි අහනවා. කෑ ගහලා අහනවා කො mug එක කියලා. හරි. So now that is a sub problem, right? මග් එක හොයාගන්න එක තව side එකකින් ආපු it's a side issue. So that is another problem then. So in order to solve that problem, you will have to shout and ask somebody, amma කොහෙද මග් එක තිබ්බේ? නැත්නම් අපි නංගි හරි අක්කා හරි කොහෙද තිබ්බේ මග් එක? ඔන්න කෑ ගහලා අහනවා. නැත්නම් අයියා කොහෙද මග් එක තිබ්බේ? So that's another solution for that problem. So once that problem is sorted out, then you have to investigate another points. Now let's say let's say one of your siblings has taken the mug and he has kept it in his room. So now ඔන්න දැන් තව requirement. Now you have to walk to his room. නැගිටලා හරි දොරට ගාලා හරි මොනවා හරි කරලා මග් එක අරගෙන you have to come back to the kitchen, you have to wash it, and you get the point, right? There's going to be a massive lot of sub flows in it. Okay, so that is where we call it as decomposition. What we do is we look at the picture as a whole and we pull out small parts out of it. We decompose the problem into small problems. So as a whole we see is okay, get the mug, yes, but in simple terms, as you can understand right now, getting a mug is not an easy thing. So there's a massive flow of that as well. So decomposition is that. Okay, so let's say let's take another example. So finally we found the mug. Now you need milk. Okay, so milk, now when we want to get milk, we have two options. Either we can get powdered milk or we can get they call it liquid milk. Okay, so fresh milk. So powdered milk, to find out whether powdered milk is available, you will have to open up a cupboard to ask your parents or someone and check if where the powdered milk is there. Or fresh milk, unless if it is not opened, it would be outside. But if it is an opened container, obviously you would be keeping it inside the fridge, right? So then you will have to go to the fridge, open the door, look for milk. Okay, so that's another scenario. Okay, now you found the milk. Okay, now you need to find water part we already sorted out. Then අපි වන්සන මොනවද බොන්නේ? කෝපි තියනවාද? So you have to find out whether coffee is available. So check which type of coffee is there. So, okay, when we take coffee, I'm not sure whether you're a coffee fan or not, but if you take coffee, there are like multiple different types of coffee, right? You have instant coffee, you have cappuccino type of things. Like there are multiple types. So when you want to brew those type of coffee, different types of coffee, you have different flows of brewing it. So now then on another decomposition of a problem. How are you going to brew it? Now there's this type of specific coffee where you need to put it into a coffee machine. There are some types of coffee where you can just instant, just put some water, just stir it and then done. One of ප්‍රශ්නය. Now I hope you got the point. ප්‍රශ්න ගොඩක් දැන්. We saw it as a one entity, but when we jump in and when we expand it, it's a massive lot of problems. So that is what decomposition decomposition, and that is what we call as analyzing a problem and investigating the requirements. Okay, so now once all these are done, we have another point where we talk about abstractions. So abstractions are you will understand it very well once we jump into the module and once we start some coding. Okay, abstraction means it's basically creating different models out of real world examples. So in simple terms, අපි coffee ගත්තොත් coffee කියලා අපි හදනවා model එකක්. So we get coffee and we create a model called coffee in the system itself. So we use that as a real world example so that it will represent something in the real world in our application or in our system. Abstractions වලට ගොඩක් අපි example නිකන් simple example, let's say if it is a school management system, we will have a model or a data type or a data point called student. So that means that's the real world representation of a student in the system. Right? So that's what the part with abstractions. I know this is a bit type of complicated, complex, but once you start doing it, it will be quite straightforward. The only thing is sometimes if the person who is teaching it, if that person is not coming from a development background, I mean from a software background, then the way they teach will be a bit different. But here I'm always using software analogy since I'm coming from a software background. So that it will be kind of easy for you guys to understand. So then we jump into programming. So programming is literally, yes, it's programming, as you can see in the video as well. So this is where we jump into the actual coding part. So programming, we do get few points. So primarily we have the option of developing the code, this part, okay, and then in there we will be mainly focusing on identifying errors, and at the same time there will be a lot of testing and processing data so that you will be able to understand what is exactly going on. So it's like this. So in the second paper, you get a question where in that question it basically asks about, gives you a example problem and it asks you to identify an error. So it will basically ask you to find out if there are any logic errors, or if there are any syntax errors, or if there are any runtime errors. Okay, so these errors we will have to practice, and we'll have to understand how to find out if there is an error. Putta, what's the programming language you guys practice at school? Is it Python?
Yesterday we changed that listen, but we couldn't do it.
Okay, you're going to use Python, is it? Python. Sorry? Don't know. Ah, okay, 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 perfect. Okay, so I wish you guys will be starting Python as well, because we do get three different options. We have three options. One is Python, one is C sharp, and the other one is Java. So from my personal experience, C sharp and Java is perfectly fine, but it is complex. So if you go forward with Python, with Python the learning curve is actually similarly less compared to other two languages. So because of that reason, most of the curriculums they actually push to go forward with Python. Anyway, I will be using Python, and you also get the option to choose while you are at the exam. So there is no such thing as a fixed, a fixed language. So that's perfectly your option to go forward. And then yes, who just joined? Hi, yes. Okay, perfect. So then we so that's the development part. So we will be going entirely from the beginning of the development, and we'll cover that part up, as well as when it comes to the development we'll be discussing about couple of factors. So primarily we'll be talking about constructs means different types of variable types, and different ways of data structures. So I'll explain this in a very simple way. Now, when you want to store data, when you want to save some data in a specific point, there has to be some sort of a structure, right? So the data has to be saved in a particular structure so that it can be accessed to process or to perform some sort of an activity. So this particular structuring part is what we will learn during the constructs module, where we will be talking about the variable types and declarations, how to declare a variable, and what type of selections are there, and also one actually important point, which is known as iterations. So iterations means loops. So whatever the processing which happens, it will basically loop through a data set, and it will try to process it, right? So that part is there, and then we will be touching base on data types and structures. So I hope you guys have done these things in the previous grades. So if you have done it, you should know what are data types and structures. But if not, yes, don't uh, don't get stressed. We will obviously cover that part as well. So there we will be discussing on different types of data structures, including booleans, strings, and different types of records, arrays, and so on and so forth, as well as the most important thing. The next most important thing is inputs and outputs. So that is also one thing specifically we will have to follow up, because whatever the information which is being sent in and taken out is specifically must be validated, as well as there will be different types of processings which has to happen, right? So on top of all these things, we will have this thing called operators. So there will be different types of operators we will be using to basically process this data for adding and different types of processings, as well as we will be learning about logical operations as well. And once these are done, then we have this point where we jump into subroutines. So subroutine එකක් නැත්නම් sub program එකක්. So subroutines and subprograms in I'll use the same example I used before. If you take something like this, අපේ coffee example එක. ඒවා එකක් ගත්තොත් එතන let's say if we think about okay I'll explain this in a very simple way. හිතන්න මෙහෙම එකක් now that particular flow, if we have the entire flow starting from the beginning, from start to the end at a single structure, it will be complex, right? මොකද හිතන්න මේ 10ක් තිබුණා කියලා, sorry, we have like over, I think we discussed about 6 or 7 actions, right? 6 or 7 activities, right? So altogether, if we take all those activities and if we try to write a complete code from top to bottom, that's going to be a massive code, ne? I කෑ ගහනවා කෝප් එක ඔය දානවා ගිහිල්ලා බෝතලේ වෙනවා වතුර තියනවාද බලනවා, right? It will be a massive code which will have like couple of 1,000 lines, and it's going to be a big mess end of the day. So for that, what we do is we use something called sub programs. So we take this entire code base and we split it into small components, smaller parts, okay? And then we use them for separate processings. Example is to find whether, let's say, find whether milk is available. We will create a function called check milk in fridge. Okay, check milk inside the fridge. So then when you call, when you run that sub program or that let's say the subroutine, what happens is it will execute a certain set of features or functions where it will check inside the fridge and see if milk is there, and then it will return true or false based on the request. Yeah, so quick question, Mehansa and Nehansa, have you guys already started it, and where are you at the school right now?
I live in Korea.
Korea, okay. So
we are doing Edexcel privately.
got it. Okay. So you do not attend any classes?
Yeah.
Ah, nice. Okay, that's cool. So grade 9, you guys already started this somehow, or right now you are starting it?
Right now we're starting.
Awesome. Good stuff. Okay, perfect. So you just now joined the first lecture then. That's great. Okay, so another question. So now about the programming. So in your previous years, like grade 8, 7 and 8, did you guys cover up any of these points?
Yeah, until the grade 7.
Until grade 7. Okay.
Yeah.
So these inputs and outputs and validations are already there, right? Up to a certain extent, I mean. Great. Perfect. Great stuff. Then it will be quite interesting for you guys. Awesome. Okay. Perfect. So, yeah, I hope the subroutines and program part is clear as well. Then, okay, so that's about the second module. And then we have the third module, which is data. So data is the most important factor when it comes to this systems and information, because okay, so you guys are familiar with AI now. I think we won't be able to find anybody who doesn't know about AI, right? So now the whole factor behind AI is entirely based on data, right? So data, so the data models, AI models everything is based on specific data points. So learning about data is one of the crucial factors crucial skills which you must have in this current world. By the way, I do teach at a couple of universities, so we do work on creating AI machine learning models. So what you learn here is actually quite important and interesting, because when we jump into creating big data models like using natural language models and explainable AI models like as ChatGPT, this information, what you learn here, is extremely critical. So you literally need to know how these calculations work and how the data is structured. Okay, so perfect. So in the data topic, we'll be primarily learning about 4 different points, which is binary. So in this case, binary, it will be binary numbers, including negatives and all, and hexadecimal. And this is primarily about calculations. So I know you guys might have done up to a certain extent in calculations. Here it's also the same thing, but getting a little bit advanced. And we will be discussing about data representation. So how ASCII images are built, how bitmaps images are created, how sound is created, and so on and so forth. So these particular points, when it comes to the representation, it really matters, because that is how you will learn how data reacts. An example, this particular call. So here we are going through Zoom, and this entire call is based on a specific type of data representation. So I do have a setup here, and we have couple of devices, so everything is interconnected and everything is using these type of different data representations to communicate. And then data storage. This is again one of the important points where we talk about data conversions, like bits, nibbles, bytes, kilobytes, kibibytes, and megabytes, megabytes, and so on and so forth, as well as compression and different types of encoding algorithms. You do get questions in the paper with these points, guys. So it's extremely straightforward and easy. It's just some straightforward calculations are being asked during the exam. But yes, we will be covering that as well. And then finally something interesting, computers. So you started learning computers and now you got into computers, okay? And then in this module, so now we actually have covered up the programming and the hard stuff. So these are now the starting from module 4, it's all mainly theory, and it's quite interesting as well, because here we'll be learning about machine and computation modeling. So yes, from grade 6, you guys were learning about the input, process, and output model. So I know, and here also we'll be discussing the same thing, but we will be jumping into the actual CPU itself, and we will be learning about sequential, parallel, and different types of multi-agent computer models. So in a nutshell, can you guys guess what is sequential, parallel, and multi-agent? Just a guess. Anyone? You're on mute. Yeah, you can just unmute and say. No suggestions. Okay, so simple. So let's say I'll take an example. Okay, you guys use IG, right? Okay, perfect. So when you want to upload a picture in Insta, so you take a picture photo and you press as upload, and while the photo is uploading, you can still browse, right? You can browse, you can check pictures, you can go forward and do whatever the things you want, right? That is parallel processing in a nutshell. Okay, so your phone is able to upload the picture. At the same time, your phone is able to browse and view pictures, do videos, send messages, do whatever the activities you want parallelly. Okay, so this gets applied into multiple levels, into different types of server side programs, and so on and so forth. But in a nutshell, that's the idea. Sequential is something else. Sequential is, we also call this as synchronous processing. So synchronous processing means you open one. Okay, simple. When you browse a website, you have to wait until that thing is loaded up, right? So the website has to load and then you can, okay, so let's take YouTube. You go to youtube.com, YouTube loads and then the video starts to play. So that is a sequence. So that is called sequential processing. So execute 1, 2, 3, 4, 5. And multi-agent means, so that is sequential. Parallel means you execute multiple events and actions at a time. And multi-agent means you actually divide this particular workload into multiple different agents as well. So that means you can reduce and split, sorry, not actually reduce, you can, you can reduce the load of a single entity by splitting it into multiple. So there are different types of processing models, multi-agent models. Example is a simple example. Have you guys seen this production factories, car factories and all, where they have huge production lines? Tesla factories. Okay, so when it comes to production factory, you do have like multiple different points, right? One point is here, so let's say if it is a toy production factory, so a certain part of the toy is manufactured here and then it's sent to sent on a conveyor belt to another location, likewise, so it moves, right? So when it moves, that has to be detected using multiple different sensors and applications. So that is a simple example of multi-agent platforms, where you have multiple different applications and agents working synchronously together to perform a single action. I know it's a bit tricky point, but it will be clear when you guys get into the theory module. So then, we'll be discussing about hardware. So we have CPU, memory, and storage. So these are just talking about hardware factors, how hardware works, the concepts behind hardware, and what type of applications and usages we have based on different CPU types, memory types, and storage types. So if you guys watched any tech news recently, you might have noticed that NVIDIA released a new VGA card, which is known as the NVIDIA 550 series, and at the same time, Intel and AMD and Snapdragon, everybody released different types of CPUs. So we have different types of CPUs for different types of activities: computing, mobile, gaming, and so on and so forth. Okay, so we'll be learning those stuff, and also we'll be talking about the cloud. And so cloud and embedded systems. So cloud is again something really, let's say, important to learn, and one of the most hype topics, because now technically about 90% of our activities spent and saved in the cloud. When you upload a picture on, let's say, Facebook or Instagram or TikTok or any other location, that is getting saved in the cloud. When you send an email, that is saved in the cloud, and all your activities are saved in the cloud, right? So those points we'll be discussing that as well, and then we'll be talking about embedded systems. So embedded systems are also a specific type of applications where, user specific type of hardware, which we will have let's say, okay, an example for an embedded system. Okay, let's take a simple elevator, a lift. Okay, so the lift has a specific purpose, right? The lift's purpose is to take people from one floor and take them to another floor, right? To travel between floors in the building. that is it. No? Now you are not going to take the lift and take it out and drive it home. It doesn't work like that. So now for that we use embedded systems which will have only one particular purpose. So older TVs, not the smart TVs now, but the older TVs, they also were taken as embedded systems because they had only one purpose, to display a video stream which is being provided to the screen, right? So they were taken as embedded systems. But nowadays TVs are like so smart now. They have like multiple different capabilities where you can install applications and so on and so forth. But the whole concept behind an embedded system is that, so you have an application or a system which will perform only one specific task. Okay, so after that we jump into logical statements, and also we'll be touching base on truth tables. So logic and logical statements, that's the next most important point, because this is the core of everything. So you guys know that programming languages, so we do have well, we have like a vast array of different programming languages now. So the idea behind a programming language is to technically, because we can't write binary code, right? So when we want to talk with the PC, there is no way for us to communicate because we can't speak binary. I can't just say 0 1 0 0 0 1 0 something like that. So for that, the only option available is to convert it into binary, and what you do is you use a programming language, and that language, what it will do is it will basically convert that particular coding into binary, which will end up executing a certain set of logical statements, which will end up triggering some electricity inside a circuit. I know it's a bit of a full flow. So we start by, so inside the CPU itself, what we have is small transistors. I will show you guys some interesting stuff. I do have a lot of PCs lying around here, so I can show you guys some old hardware and all. So inside a CPU, what we have is simply a lot of, like a bunch of transistors, right? So these bunch of transistors, when you provide power based on the active gates, it basically triggers a logical statement. So in order for us to understand exactly what type of a logical statement which has to be triggered, we need to learn how to write these logical statements and the truth tables. So the truth tables are the points which will be basically learning on how to provide this software with its actions. So after that, after the truth tables, we'll be talking about software, operating systems, utilities, and of course applications. So this is an high level pointer. So you do get few questions in the paper for about operating systems and software, but not that much. So it's nothing something complex. Then we jump into the complex part where we talk about programming languages and high level and low level programming. So that is again a point where we need to put a bit of a effort on learning, because that's a core concept. Okay, quick question. Just a raise of hands would be do. Any idea of becoming a software engineer? All of you. No plans. Okay, perfect. No worries, no worries. So, but then again, if you have have at least a slightest idea of getting into the software industry, learning this is actually quite valuable, because this particular part about the assemblers and the compilers and the interpreters, that is something which is fundamental when it comes to building applications, which you need to know as a fundamental point. Okay, and by the way, software industry is actually booming in the next 5-10 years. with the AI being getting advanced day by day, mostly there's a certain set of job roles which is going to get replaced. So, okay, I'll tell you guys, it's a good example. Now, I do have a software company. So in my software company, about 3-4 years ago, when we wanted to get something done, like a design done, we had to hire people. We literally got people in to basically do the designs for us. They used online tools, and they charged us a certain amount of money. But now, with all the AI features which we got last year, now we don't use people for that. We just get AI to generate images and the posts, and that particular job is completely gone now. So people who was basically in those jobs, like connected to those jobs, either they had to move out, or they had to change their career to align with the current available market. So keep an eye on the market as well, because AI is not replacing our jobs, but there are a certain set of jobs which will be replaced eventually. And you know what? I recently spoke to a doctor. Recently, this is like a couple of days ago, and he was actually worried. What he said was, there's a big chance for AI to replace doctors, not surgeons who do the surgery and all, but the typical doctor. There is a massive chance for AI to replace a normal doctor, because once you get your blood work done, you can actually upload it into, there are like medical grade AI systems, and it will give you the full report. So that is where the future is going forward. So learning IT and with these data structures are extremely important, because whatever the job role you want to get into, this will be quite relevant and important. Okay, super. So quickly, let's jump into the last two topics. So communication and internet. So these two topics are entirely theory. Okay, so theoretical topics. So it will be quite straightforward for you to understand. So this networks. So the networks module, we'll be discussing about the different types of networks which we have, local area, wide area, and so on and so forth, and wired and wireless networks, as well as we'll be touching based on topologies. Have you guys already done network topologies? Yes or no? No. Okay, perfect. Okay, so then we'll be going very in depth in it, because for advanced levels, they do ask for the questions, but advanced level theory, you don't have any theory in the advanced level book. So they basically teach everything, the basic stuff in here itself. So that's good. Okay, so then we'll be talking about what is known as protocols, network protocols, and packet switching. So I'll hopefully will show you some interesting networking stuff as well, how the internet works and so on and so forth. And then we'll be talking about the network security, attacks and defense, and at the same time we'll be talking about the internet and the World Wide Web. While we are on the topic, let me ask you a quick question. Where is the internet? I know it's a weird question, but where is the internet? Internet එක කොහෙද තියෙන්නේ? Yes. Any answer is an answer. Yes. මොකද ඉතින්? What do you think? Ethan, what do you think?
From the router.
Sorry?
From the router.
Yes, from the router, correct. But in the world where it is?
from stations.
From base stations, correct. Correct, up to a certain extent, but I'm looking for a specific word. Yes.
Through protocols.
Through protocols, correct, but where's the physical network? Where is it, I mean?
Satellites.
Satellites? You said satellites, is it? Okay, so internet, the internet as you know it is actually in a different place. Huh? So let me quickly show you that. So give me 1 second. Give me a second. Okay, so let me take this. So the internet as you know it, actually it's here. So you can see, technically speaking, this is the internet. Okay. So hold on. Cool. Yeah. So here you can actually see the cables. Okay. So these are the cables which you have undersea. So all these are literally all of these are small. See, all of these are points which will basically connect the countries together. So let me zoom in and show it to you. Okay, so see, all of these are actual network cables. Okay, so these are undersea cables. All of it is under the sea, and this is how we get internet. So here in Sri Lanka, we do have 4 entry points into the country. So if I zoom it in, you can see one entry point is in Colombo, and the other one is in Ratmalana, and the other one is in Matara. Okay, and we actually get the internet through these cables. So if I click on this one, you can see cool. Where's Sri Lanka now? Yeah, okay. Hold on. Up, yeah, see, if I click on this one, you can see this is, why can't I click? Yeah, see me V, where see me V? See, yeah, see me V. Okay, so these are the different types of cables. So literally, what you see here is the internet. This is the actual internet. So it's all about undersea cables connecting all the regions together. All the regions are interconnected, and that is why. So see, this is how the entire world is connected together. All the countries and all the data is traveled through here. And the fun point is we have couple of primary data centers. Now here you can see, if I zoom in, sorry, you can see this is Singapore. So Singapore has the one of the largest data centers and data points, because most of the cables crosses through Singapore. So that's why for us also having our servers now in my company, most of our servers, production servers, are deployed in Singapore, because we have a direct cable from Singapore to Sri Lanka. See this purple color cable? CMEV. See it? So this CMEV 5 cable is actually directly coming from Singapore and it ends in Sri Lanka. So because of that reason, we have a extremely high bandwidth. Also, we have a direct cable coming from India. This one, Bharat Lanka cable system. So, likewise. Okay, so I just want to show you guys, that's the internet. Huh? So, if somebody asks you what is the internet or where is the internet, don't say it's up, say it's undersea. Okay, so let me push this up. Nice, perfect. Okay, so yeah, likewise, I'll show you guys some interesting stuff. Huh? Let's once we jump into the topics, it will be quite interesting. Let's see. Okay, so that's about the communication, and then we talk about the bigger picture. So this bigger picture is again a point where you will get a lot of questions of like MCQs mainly, where it basically captures the point about environmental impact, the ethical impact, and the legal impact of to the society through the advancements of IT and systems. So here we talk about specific type of trends like quantum computing, why we like new AI technologies and all sorts of different let's say different technologies available. Okay, so this is again going to be theory part, and yes, and then there we wrap up all the topics. So it's quite simple now. When it comes to the process, guys, it's straightforward. You have 6 topics, and once the 6 topics are done, you can jump into the exam. So okay, so I have a few bit more. So let's jump into the papers as well. Yeah, Ethan, have you guys did the school discuss the papers with you? Paper structure and all. Have you guys? Do you know the paper structure so far? Okay, perfect. No worries. And I hope other two, you all also good, perfect. Okay, so that's perfectly great. Okay, so the assessment. First of all, remember, like whenever you start something, first of all find out how are you going to get the final result. Whatever said and done, the certificate matters, no? So the end certificate is the goal. So we have to know that as well. So according to the IGSCE specification, we have 2 papers primarily. Okay, so the assessment is split into 2 papers. Paper 1 is a complete written paper. So it's a pen and paper where you write the answers, and for that you get 80 marks, total of 2 hours. Okay, so you literally need to just sit down and write that, and from all 6 topics it will be comprised. It will be compiled using all the 6 topics which is available. And then we have paper 2, which is the application of computational thinking. For one is known as principles of computer science. Second one is application of computational thinking. So the second one is the tricky part, where you get 3 hours, and for that it comprises of 2 different versions. We have the pen and paper where you have to write, as well as you have the coding. So this is where you will be basically going to an examination center, which must have a peer, let's say a lab, a computer lab, and in that computer lab they will guide you, and you will be given up the details on how to start and how to complete that particular paper. So this is how it's structured. So paper one. So we are talking about the code 4C PO-01. So this is the international GCSE code. So this is the first paper, paper 1, which is the principles of computer principles of computer science. So this will be asking from all the topics starting from topic 1 to 6, and it is created based on multiple choice, short open responses and extended open response questions. Okay, so multiple choice MCQ, quite you guys are familiar with it. So you get the questions, you just tick it off and call it a day, right? But you just need to be careful with the short open responses and the extended open response questions. So short open response questions, I think you guys might have done that before as well. You had it in your previous exams. So short open, in this case also, we just need to make sure that the answers are written to the point. And in Edexcel, it's a bit easy, okay? Because in computer science Edexcel, you need to make sure that you follow the exact keywords. So when you're writing the short open response question answers, the primary point you have to focus is that you will stick to that particular keyword structure. So if the keywords are there, you can immediately get the full marks. I will show you guys, since since we have access to the Pearson education portal, we can see how the how these responses have been provided by the paper marking scheme itself. So you guys also have access to that, so we can actually study it and see how these responses are structured. So based on these structured responses, we can actually come up with the particular structure. And then also the tricky part is extended open response questions. So when it comes to extended open response, your answer has to be an essay, number one, and it should be structured in a particular way where it is following the specific requirements. Example is last year, no, that question was from the A-level paper, but it's actually quite easy. Last year A-level paper, we had a question where it asks, it showed a picture of a vending machine, and the question was to write the activity flow of the vending machine. Quite straightforward. But the thing is, that's a 12-mark question. So 12-mark question means you basically get 1.5 pages to write it down. So the expected answer was actually a very complex, tough answer where in the marking scheme, they mentioned that the student must write the entire set of activities. You guys will have to watch this video back again, since I explained this flow to Ethan at the beginning of the lecture, where we talked about like making that coffee. So Ethan, the question was similar to that, similar to making of that coffee. It asked how to structure the flow of a vending machine. So you have the basic actions like put the money in, select the item, wait until it gives out and you get it. So it's just, you can write the answer in 2 words, like 2 lines, but you don't get marks. In order to get full marks, you have to write it in a 1.5 page essay. So those type of things has to be, we have to be extremely careful. So that's the extended, and then one longer 6-mark discussion question, which something like which I just mentioned, and it's guys 2 hours, so it's total 80 marks. Right? Now then the paper 2. So the paper 2 here, this is mainly focusing on the algorithms and the programming logic. Okay, and primarily this focuses on topic 1 and topic 2. okay, because this is entirely focusing on the programming part. At the same time, there are some questions which will ask you to write an answer. So some pen and paper questions are there as well, but mainly it's the programming one. And the programming language, you do get three options. You get Python, C and Java, C Sharp and Java. One we'll be going forward with Python because I select Python due to three reasons. One is Python is a scripting language. We'll go and we will go in depth and understand what is a scripting language later on. But in a nutshell, scripting languages and compiled languages works in two different ways. So scripting languages have a method where when you type the code and when you type run, it executes the code then and there. Compiled languages, when you type the code and when you run the code, it has to be compiled. So in order for you to run a compiled language system, something like C Sharp and Java, you need to have your PC ready, installed and so on and so forth. But Python, now since Python is being used for AI stuff mainly, we have the Python API and online versions which we can easily run Python code and test, as well as you have a vast array of support documents and help for Python, since Python is the primary language, the programming language behind AI and data mining and so on and so forth. So it's going to be quite easy for you guys to learn, as well as there's like millions and millions of YouTube videos and tutorials and stuff which you will be able to use and understand. Okay, yes, so because of those reasons, I'm going forward with Python as well. And also long-term benefit, learning Python will obviously help you in your long-term career over the future, because whatever the career path you are going to use, these type of data mining would be used at some point. Okay, and then lastly, you get one long 20-mark problem, where this is the trickiest thing, where this will basically give you a case study and ask you to build the code. So this is what we need to practice a lot, because we need to try out these questions and understand how to basically write it. So it's nothing complex, but you just need practice, because that's focused on giving a software-based solution to a problem. Then the total is you get 3 hours and 80 marks for the paper as usual. And that's it. So you do those 2 papers and that's done. Okay. So final point about the strategy. Okay. So this is just a strategy which I am suggesting. This will not match for everyone. This won't match everyone, and each and every one of you students have your different ways of learning. So use this as a strategy, like a base point, but you will have to tweak it and adapt it according to your requirement. Okay. So the exam strategy, what I suggest is for paper 1, so there are 2 strategies for the 2 papers. So paper 1, it would be basically what you get is you get 2 hours, that is equivalent to 120 minutes, right? So if you spend 1 minute per mark, okay, 1 minute per mark, don't get this thing confused, not per question, 1 minute per mark. So that means if you have a question where you get 4 marks, you can spend 4 minutes. Got the idea, right? So likewise, if you spend 1 minute per mark, then you will be able to finish the paper, plus it will leave you 40 minutes to review. So then you can take your time and slowly review the paper back again and try to check and see if you made any mistakes or if everything is 100% correct. At the same time, for the paper 2, you get 3 hours, which is 180 minutes. So that means if you take it as 1 minute per mark for written questions, which you have 25 marks, that means 25 minutes, and 150 minutes for programming questions, that means 2 minutes per mark, and final, it will be something like 20 marks for the final programming question, so which will end up in 40. So that will kind of give you 35 marks. I know this is not something which we need to discuss at this point because still you guys are not jumping into the paper. But then again, I will keep this as my mantra and we'll try to memorize it to you guys so that later on, once we get into the system, we can try and see how it works.